Welcome everyone, and thanks for being here. I'm Adriana, and today I'm gonna talk with you about ML production pipelines and specifically about a classification model we have been developing. We have been wrapping up Python, MLflow, and Git to create a production pipeline. My talk is going to be divided in 5 points, so I will briefly explain you a bit about me and data insights, how everything started and why we decided to go on machine learning pipelines, and how was our approach. Afterwards, I will explain you a bit how Databricks helped us in solving these issues and the challenges and improvements we would like to apply in the future. I'm Adriana. I've been data scientist in data insights since the last 5 years. And in the last period, I've been concentrating a lot on machine learning production pipelines, and that's why I'm going to present this topic to you today. Really 2 words about data insights. We are a fast-growing startup consulting company providing like data science, big data, and cloud solution to our customers. Our idea is to really try to support our customers from the ideation to the production rollout of different data projects. So let's now start with interesting things, and I'm going to explain you a bit why we decided for classification models. So we have been discussing a lot with my colleagues what are the projects that are mostly used nowadays in industry, and at least in our experience. So for example, for the German market, classification models are really used a lot. Classification models are these models that from every data set tries to predict which entity is going to fall in which class, let's say. Specifically, or actually more less theoretically, let's talk about the predictive maintenance use case. We have, for example, a machine, and we want to try to predict if this machine in the future is going to need maintenance or not. So these models are really answering questions with classes: yes, no, red, blue, green, and so on. We have been collecting the 3 main business cases we have been working on. So for example, predictive maintenance, churn prediction, and product recommendation. But we have the feeling that these kind of projects and models are gonna heavily be used in the future. And that's why we decided to make our framework or machine learning framework in production using these kind of models. We started to develop a POC, and that's where everything started to basically go bad. After 3 weeks of work, we had a Jupyter notebook. I'm sure most of you know what it is. So it's a notebook that many data scientists use to explore the data set and implement it, make several trials, try to find the best model. And so at the end, after 2 weeks or 3 weeks of work, we found out we had a single Jupyter notebook that was a solution, but was working on these really small data sets and was working just on a local environment. Okay, so actually we actually realized that from the proof of concept we developed, we were still missing a lot of things to get something production ready. The first important things we were missing is a constant way to do development and training. This is not necessarily what have been used in software development and production code so far. But with MLOps and machine learning models, it's really important to get a process to keep training your model and keep changing the things you also have in production. So this was missing, and then we really realized that the software development standards were also not there. Having a Jupyter notebooks where everything was running in the same environment locally was not what was required to just hand over it to operations. We needed a shared environment, a way to monitor, model, version it, and actually secure our data. And that's where we start making some thoughts, and we decided to try to solve every little issue step by step. And that's how we basically did it. The first idea was to try to modularize our code. We had a full notebook without really a structure. And from there, we decided to really create a Python library. So as you can see, this slide is quite dense. Take the time, or also after the talk, make some thought, let me know what you think. That's how we basically structure it. We had a setup.py that allows us to package the library. We have the requirement.txt that actually made this shared environment, so everybody can just use it in their local environment. We have a requirement.a README where everybody can understand what this library is doing, and the possibility to document also our functions. The second column there, you see the ML code structure, and that's basically one of the most important part of this library. So we try to modularize the notebook, getting the extraction part, the data analysis part, the modeling, and the visualization. Modularizing everything made our life easier to create unit tests and also to control everything through a YAML file. This is something I'm really a fan of. So using YAML file to control your flow. And that's something I really suggest you to do. Try to write and create your classification or machine learning custom library really generic, and try to control everything through the YAML file so that you don't have to change your Git folder every time. And we were like, wait, great achievement, that's amazing. So we have structured code, we have functions, we have requirements, we have versioning, testing. That's amazing. We can also run our script out of the box. And there Mr. Chicken came again and said, hey guys, wait a minute. We are still missing a shared environment. You are still missing security level, and you don't have actually a production ready architecture. And that's where we start thinking how to solve it. And we decided to go for Databricks. Also here, I try to really give an idea which architecture we decided to use, and I would like you to focus in the 4 big categories, or the 4 big technologies that are playing a role here. It's the Git repo, so we have Git that take care of our custom library and take care of uploading this to the cluster. Then we have the Databricks cluster that allows us to make everything running on the cloud. And then we have the S3 buckets, so Amazon buckets that assure the security layer that is needed in production. Last but not least, we have MLflow that is actually allowing us to do all the maintenance of the model that till now we were missing. Getting a bit more deep into the first step, so how Git is helping there. This is the part that we try to develop in order to solve the CI/CD issues. So to have a continuous integration, continuous development framework, and this we did it using Git actions. You can check the code, take inspiration. The main idea is that from our custom library, we package the library as a wheel file, and every time we align the Databricks cluster with Git, with the Git master, uploading every time the new version of the classification model in the cluster itself. And that's our pipeline. So after we have the model and we have all the functions tested and running in our package, we have it in our cluster, and there we can actually, through the YAML file, we can design two different pipelines, the train and the scoring one. This is super important. We need to really keep an eye on having the training pipeline divided from the scoring one, because there will be way more times that you need to run the scoring and way less time you need to run the train. So the way of supporting operation and debugging it, it's really important to keep it divided. As you can see here, we have 3 different Databricks notebooks that allowed us to keep this sharing environment, allow every data scientist to try out and play with it. We have Databricks, we have Amazon that S3 that secure our data. The data gets into the data analysis part, and then we decide to do the training where we train the model, we stage our model in the staging pipeline of MLflow, and then once we are ready, we move it to production. The scoring pipeline, on the other hand, it's gonna just retrieve the data from the S3 bucket, read the trained model from S3, and then producing the scoring. And after that, we were also quite happy. We said, that's amazing. We have a shared environment, yes. Now we have a security layer for the production data, quality checks on the data through the data analysis notebook. And then we have the CI/CD. Okay, we are ready. What do we need to do next? And then Mr. Chicken came again. He was quite sad and said, hey guys, you're still missing something. You're missing the tracking part of your machine learning experiment. You're missing the model versioning. You're missing the storage and the serving. Now, for all of you that have been following till now, I'm guessing you already know what I'm going to talk about. And actually, here you are. We are going to present you how we used MLflow and how MLflow. Okay, so here we are. This is our architecture that we have been seeing through the entire presentation. And now I would really like to walk through the training notebook with you to explain where really MLflow changed our life in bringing machine learning to production, and where you can really use the benefit and see the benefit out of it. We are now in the Databricks notebook space, and in specific, we are checking the train notebook. Here, I would like you to keep an eye on why we use MLflow, why MLflow is so helpful in bringing modeling to production, and things you should take care, and what you should actually take care in the next, when you're developing this kind of step. The first things I would like you to notice is the mounting part. We have been showing in the previous slides that all the data have been stored in S3. And now if we mount the S3 bucket in the BFS, this would allow us or make our life easier once we are using MLflow. Now, I will not show you that everything runs, but I just did it. Here, it's another really important thing. We have been using here the classification library that has been packaged. So this is actually the part where I'm calling the function I'm interested on. I use basically all my classification model that I've been developing in Python as an external library. Here we are actually customizing our configuration. As we said before, all our modeling and pipelines are controlled by the YAML file. And here we have the options to manipulate or to change the single variables if we want to use one data set instead of the other, or we want to use one target instead of the other, or we want to call a model a specific name, and so on. So this is actually where everything is decided and controlled. And after doing this, we will always have the possibility to go back to see the history of the notebook and to be able to rechange what we need to reproduce the data that we want to see. After dividing the training and test split, as always, we step here into the most interesting part and the key part of our notebook, and that's actually the tuning, the model tuning, the model optimization, and the grid search functions. Just to give you an overview, so grid search is quite specific. We are actually using scikit-learn pipeline here that have been tested in the unit test part, and here we are just training online, calling the grid search. In order to optimize the model, grid search is cross-checking all the hyperparameters that we have defined in the YAML file, and here it's actually when the best parameters have been chosen. Where MLflow can help us here, it's actually in taking care of what is happening, in visualizing what is happening, and also make the life easier for data scientists that need to prove or to show to the business what is actually inside, what is happening inside these notebooks, let's say. Here we store the MLflow part, we store all the runs that have been produced in the grid search. And here is just an example how you can test and visualize all your models. Let's see here, for example, we can check any specific run that has been stored. Here you have all the parameters, we choose really few, you can have 1,000, you can decide what you want. Here you have the output, and we didn't register any artifacts. So what we do now is to just store the input and the output of each and every run in order to have a look if we can better tune the model, how we can move, if the decision we have taken are correct or not. So here, for example, let's compare two runs. It's really easy to see what's the difference. So what are the parameters that have been changing when it have been these two runs have been stored, and what has been the output. There are many possibilities to plot these results, and so a better possibility also for the data scientists to interpret and to better optimize the model itself. This is something really makes my life easier at the customer, because allows me to better show why I took these decisions and why the model is behaving in this direction. So after using the UI that is making everything more cool and interesting, we can go back into our teching notebook, and here we register our best model. So the output of the grid search is not only a bunch of trial, but it's also the best parameter based on the need on the functions that you have been chosen. In our case, it was the AOC. It can be many kinds of matrices that can better evaluate the model itself. Here we have, again, the AOC. We calculated different results, and then we store the artifacts. So the point here, and I would like to show it to you also in the notebook, so in the Databricks UI, is that you have different artifacts. I've been storing the results, so I've been storing the intermediate data I've been using to train and test, and I've been packaging my trained model. Here I have everything ready in order to call the model once it's on staging or on production, and to directly provide a prediction and a scoring to my train set. So here is how my register notebook is gonna look like. You actually see some differences between the runs I've been showing you before. So we didn't have tags, but we had the artifacts, and we have additional, we have the possibility to actually move this to production. What does it mean when I move this to production? Once you register the model and you give it a model name, the MLflow is gonna check if this model name exists, and it's gonna create a new version if an old version is already existing. This is actually amazing. Like, as a developer, there is so much mess inside training, which train, what's the best model, how we store it, and which version, and when. This specific thing of MLflow, of taking care about all this for you, it's amazing. And it's, I don't know if you have been working with this before, but this is really exciting. Here I automatically also move the register model into the staging part. What does it mean? It means that we store the results, we go here, we have my multi-class classification model, I have the different versioning, and as you have seen, I've just stored the version 7. So I'm here, I don't have particular tags at the moment, but I have a specific input. So my model is already expecting specific columns in order to predict the result. The model, it's already providing 2 outputs, and here I've already done it, but I show it to you again. The possibility to move my model to production. So now I go quite quick because we don't have much time, but the idea here is that we can move manually, and at least I like it to make it manually, because bringing things to production needs to be done in a really cautious and conscious way. So once we have the stage in production, we can see here that my serving is ready. I have version 7 in production, and we are ready to go. We have our best trained model, version 7, and it's ready to just be called. Okay, so now I would really like to close the circle to show you how our prediction notebook is gonna look like, and specifically how the batch basically scoring could look like. As you can see in the ML library, so in the first cell here, we are still importing our core library, our core machine learning Python code that is contained in our Git repo. This is then gonna follow by custom installation and the configuration based on the last requirements we had in prod. This is actually where all the magic is happening. MLflow is automatically checking which is the last version of this model in production, retrieving all this information and retrieving the model URI. So basically he knows exactly the location of our model. As you can see, I just plotted here the latest version, production version, and here I want to show you how the scoring is done. I created my input data set, I create the data set that I need, I retrieve the pipeline from the URI that MLflow just got, and I get my predictions. Here I'm just making them a bit nicer, and here is more or less what you would see stored back in your S3 bucket. So for each customer idea, you have the real classification, so how it's exactly the output should look like. And this is the confident that our model is telling us if this particular customer is gonna churn or not. So therefore, this is let's not concentrate too much on the numbers, but this is more or less the idea of the output. So we can just read back the last production model version and to process our scoring data as batch. Okay, great. So as you have seen, we achieved a lot of things. So we have now production model that is stored and secure in S3. We have the possibility to serve the model and to call it as a REST API or as a batch script. We have a cluster that always have the last version of our custom library. And we developed everything using two simple pipelines. So this is really important when you hand it over to the DevOps team. So the possibility to really have a simple process they can keep an eye on and can actually easily understand what is going on and find solutions. So that's what we achieved so far. The next steps we would like to do or to develop in the future would be an alerting system in order that like when something fails, we will get to know. An orchestration part in order to run multiple machine learning models together. And we would love to try the new one node cluster option that Databricks has, since we mostly use native Python code. And so we never actually need to use the Spark cluster with multi-nodes of GPUs. So that's it for me. From my side, I want to thank you and thank all my team to actually develop this. I'm open for your question now, if you want, or write me an email or contact me as much as you want. I love to talk about these things, and I would love to know your opinion about that. Thanks.